Hello, hello. Welcome to the Plasma Implementers Call number 25. We've got a great, great time planned, and some happy smiley faces, so that's exciting. Why why don't we start with our updates, and let's do the Matic. Wait, Matic.
Yeah, Matic. Yeah, so we have been doing a lot of maintenance work, which means like looking at our code again, writing more tests, fixing some bugs from the contract side. So I haven't been working on something path breaking right now. And other than that, our focus has been on our POS layer. So as I spoke in one of the calls before, like we also have a POS layer in between Plasma and between the Plasma layer and the main chain. So that POS layer, the validators in that POS layer are responsible for checkpointing blocks to the main chain. So yeah, we have been working primarily on that, and Ashish has been working on staker economics. So how will the validators come and stake, and what are the slashing conditions and things like that.
Yeah, so those specs are like still in progress. We are working on that, and from the contract perspective, we have added staking mechanism and some even people with small amount of stake can also delegate to some of the stakers and that kind of things like that.
Yeah, delegation. So people with small amounts can come and delegate to existing validators and earn rewards.
Cool.
Can I ask questions? Is this a time to ask questions?
Go for it.
So I wonder if there is a block and you run proof of stake. I assume that multiple validators need to kind of sign a block or something like that. So it's just, if everyone can submit a block, then one validator could kind of ruin the chain, right? Put some dirty dark block into the chain, and then the whole proof of stake is kind of messed up, right?
Yeah.
So I assume you need like a 2/3 majority vote before something goes in. And I wonder how you do the signature verification on chain, because that can become quite expensive if you have, let's say, 256 validators.
Yeah, for that, basically, right now in our current contract, we are using those EC verified signatures only. But obviously, for like 250 or more than that numbers of validator, it will be expensive. So we are working on BLS signatures, and so that basically we can submit a single signature and add one bitmap.
Super cool.
So we did 2 POCs for that. One was ZK Snarks. So we put all the signatures in a bucket and then simply verify the proof on chain. So that was quite expensive gas-wise. And our other POC was BLS based. And apparently there's some EIP which, if included, would greatly reduce the cost.
So basically, for the G2 curves, that EIP will be included in the, I'm assuming in Pittsburgh. So it will be even more cheaper to verify than 400 or even 1,000 validators on chain.
Cool. I'd love to see that code when it works. I mean,
you can have a look, and it would be great to have your review as well.
With that, LeapDAO, do you want to give an update?
Oh gosh, I don't know where to start. Carl, I'm super sorry I missed the last calls. There was always, I was hiking in Norway, I think, so I wasn't allowed to bring a phone or anything. But what are we doing? I think I mentioned that we have this Prime Casino where people can bet on very big Prime numbers, and then they are computed off-chain and committed on-chain, and then there is this computation market that makes sure that things happen well. And we are currently in the process of taking the back end of that and basically making sure that any computation that is committed in Plasma is challengeable in the same way. So whenever you have a block which contains some contract execution, then this computation market jumps in, and if there is an exit related to that block, it will kind of whitelist the transaction, only then allow you to do exits based on computation. So this is something that's moving from testnet to mainnet right now. And what else? We have an ecosystem circle where we kind of play with things. So there is one project that will happen at ETH Berlin, which is called Planet A. It's like it's a serious social game that is supposed to teach crypto economics. I'll send a link in the chat later. And it's the tragedy of the commons, kind of. It's a plasma game. And it will happen there. And then we are preparing something for a party congress, which is, the Volt Party. It's like a European party. And they want to do quadratic voting. So we do that at their congress, which is the beginning of September, using quadratic voting contracts on Plasma. Yeah, that's all the updates, I guess.
Wow, that's cool.
I see that sparkling in your eyes. Great. Message delivered.
Cool. My goodness. I guess, Will, do you want to update some Plasma Group stuff?
Sure. Yeah, so we're working towards the OVM implementation on our side, just the building blocks for building different things on layer 2 and like a reasonable on-ramp for other people, and getting close to completing that, hopefully only a couple weeks out, and then shifting over to one of potentially a few different things after that, one of which could be implementing Plasma on the OVM.
Nice. The OVM is great. Crypto Economics Lab, you want to give an update?
So we started implementing for the client stuff based on OVM as well. And she has started implementing basic decider and quantifiers in client. And I started putting universal decision contract. And then he started writing and the L1 adapters and out networking system and stuff. And yeah.
Networking stuff, networking system between client.
That's pretty much it.
Nice.
Yeah, we have some unclear points, so we want to ask later. Thank you.
Great. By the way, where are the contracts online on GitHub?
Oh, we haven't, we just started it, so
Got
it's
it.
gonna be there soon.
Okay, great. Who else is on the call that I missed? Is there anybody? Oh, the matter, Alex.
Well, as you know, Carl, I'm not actively working on Plasma. I'm here only to help you if you want some ZK stuff. So for now, I work 100% of my time on a precompile, which would allow much cheaper calls for pairings and wider variety of curves. So I'm not as a direct contributor, more like a support.
Well, you are amazing, and I'm always interested in just generally what you're doing. I feel like everything is Plasma at this point.
Well, we can chat after the formal part is done.
Great. Okay, I think Andy, do you have an update, or Max?
Okay. Hi. So this is from Misego, and the current work we're working on is still like the abstract layer design. We are on the context side, and also recently we just kicked off the Elixir part as well. Yeah, and I think the next update will still pretty much the same because it's gonna take long to finish everything there. So yeah.
All right. Well, I have a few things that I'm interested in talking about.
And there he went.
Things, please think of them and bring them up. I know you.
Carl, you're breaking up a little bit, or is it only me?
It's not only you.
Carl, yes, you are breaking this. Hello.
Man, he made us so excited, and now he left. He's
Sorry
back.
about that. And we're back. Yes. Anyway, sorry about that. Had to switch Wi-Fi. So if anyone has anything they want to bring up, please do. First topic that I'll just throw out there is how is everyone dealing with the networking layer? I can give a little context. The Plasma contributors chat, someone asked, I think it was Georgio's, about how people are working on dealing with the networking layer, how they're sending transactions to the operator, to each other, sending proofs. And I know that we at Plasma Group have been thinking about this, and we're basically just at this point, we're just saying, okay, let's create a library that gives us a client library that gives us a common interface, and then we can plug and play a point-to-point messaging backend. And it can start out as in a testing environment as a centralized entity that's just routing messages, but eventually it should be at a peer-to-peer layer. So I wonder if folks are working with that. Does everyone just say, oh, let's send transactions through the operator? How does that work for y'all's implementations?
Yeah, so me and Georgios basically started the whole conversation. So the point was basically every user will have basically the data availability problem will be kind of solved because everyone will have all those transactions. So at the time of mass exit, they can just provide the data and exit basically. But there are some concerns like why anyone won't spam the users, or we need to add some kind of security layers on top of it, and how the design should be basically. So I forgot his name. There was this guy who kind of offered some kind of design mechanism for which in that case you need to put some tokens in order to buy that P2P domain name kind of stuff. And yeah, there was basically the whole design. I'm not sure he's in call or not, but yeah, I'll share the basic summary from him. And we were also discussing that we should start a PIP for it basically, so that we can start conversation there.
I'm not sure I got it right, but we basically just on our side we just use Tendermint and what comes with it, and there is a JSON RPC that we expose, which is partially compatible with Ethereum, so you can do balance off calls and all these kind of things in the same way like you do on Ethereum. So you just, the idea is when you write an app and you want to move to Plasma, you just switch your provider over. You keep going. So why did you guys choose to kind of implement
No, we didn't actually implement it, but we were just like discussing that, let's say, even in your case, that tendermint node is down or maybe operator is down, then also users have the whole data basically.
I was assuming, yeah, I get it. So I was assuming that when you talk to the app, you have your own node, which synchronizes peer-to-peer and is not an operator. So it's just a read node. And then if that goes down, it's kind of your own fault. And right now, in the minimal viable Plasma, it seems like every user needs to be a full node. Otherwise, they're screwed anyway.
Yeah. So basically, we were trying to minimize those resources for users. Like how he can just basically, let's say some user loses his data, so that through the P2P layer he can resync, or obviously if he runs the full node he can already sync. But the whole conversation is in that Plasma group, Telegram group. You can just go through and we can.
Yeah, sorry, I didn't catch up. I will.
No.
So you use Tendermint, and Tendermint just does it come with a peer-to-peer network that like syncs, everyone syncs? It's like just some kind of
exactly. I don't know which lib they use, or if they implemented something. They use something in Go, I guess. And then they have an interface which they call ABCI. I don't know what that stands for, but basically every time when a transaction hits the mempool, it calls you, and you're supposed to return like true or false. And every time when a new block hits you, it calls you and you're supposed to return something. And that way you can kind of intercept all the important points. And to Tendermint, all the transactions look like bytes, so it doesn't even interpret them. And then you have to parse them yourselves and make something out of it.
Cool. Yeah, that's something that should we should definitely look into using that in the backend maybe.
I think cooler than Tendermint now is Substrate, but when we started building, Substrate was not around yet. So I wonder if anyone's building on Substrate. That would be interesting.
Yeah.
How is it Substrate? This thing from Parity. Yeah.
And and they have a peer-to-peer layer that's pretty solid, or? I
think they use the P2P Substrate.
Yeah.
Okay. If I'm not wrong, yeah.
Yeah, because I'm super interested in. I mean, all of these solutions need a networking layer that are for transmitting these history proofs, for instance. Like I think we need some kind of way to send different peers messages, and they're like challenges with how do we serve just the history that people want, and I don't know, hopefully we can have like a standard peer-to-peer layer that we can just kind of like plug into a backend and specify a public key, specify a message, and somehow it gets there. But I don't know. We'll see how that sounds pretty hard. But maybe someone else has already built something like it. So. So. Any other fun things? Any other fun research or implementation goodies?
Yeah, we also so last week at ETH India, we kind of did like a burner wallet DAI implementation demo with all the participants, so they could kind of buy food and beverages with the Incento wallet. So there's a third party burner wallet called Incento that is built on Matic, and that worked on our alpha mainnet code. And so we had printed special QR codes for the participants, and they could kind of just to fund the participants. Yeah, so it was a fun experiment.
Also, we had minted some of the NFTs, so that they can just transfer the NFT to the vendors and get one beer, basically.
A beer NFT.
It was beer NFT. So every hacker was was really happy that they can, get a beer through crypto, basically.
Cool. It sounds like now we have two, right? LeapDAO and Matic, both of you have like burner wallet implementations or something like this. This is exciting. This is cool.
Oh yeah. Oh, by the way, I didn't mention this, but we released a thing that we have released a thing. It's called PeepCash, and PeepCash is a mainnet Plasma DAI burner wallet that allows SEPA offboarding in Europe. So there's a service Bitty in Switzerland that does up to 5,000 euros of anonymous offboarding a year for you. So yeah, this is as good as PayPal. You should use it. Yeah. Oh well, the market maker. Yeah. We have a market maker, so you can exit super fast as well, but it's not exactly working yet.
Ooh.
But if you want to run a market maker, you can make like 3% or whatever. Jump in.
That's super cool, because we're totally thinking about doing the same thing. I think this is the way to do to solve the exit problem. What you're talking about, it's being a market maker and arbing the Plasma ETH versus main chain ETH. That is definitely the way to go.
On another note regarding the beer NFT, can I introduce an EIP that I published recently?
Ooh.
So I wrote this EIP 1948. So we were talking about standardization in Plasma, right? And I think I mentioned this before, but this one got merged into Ethereum. So this is a non-fungible data token. It holds exactly 32 bytes. And I think it's a good way to kind of do standardized data on and offboarding to Plasma as an NFT. So basically, if your data is less than 32 bytes, you just write it in. But if it's bigger than 32 bytes, you use some kind of authenticated data structure and do something else. And we've been using this in a couple of contexts. So for example, we've done this movie rights trading at the Cannes Film Festival, and every movie was a EIP 1948. And then we are doing at Planet A, when people emit CO2 or they lock CO2, it's written into their, we call that passport, and it's also 1948. And for the voting project that we do, the quadratic voting, you kind of need to keep a score how much voice credits you've invested already. And we also use this data structure, and it's totally possible to kind of exit these onto the mainnet and then deposit them into another Plasma chain or into another side chain or whatnot, right? And so that kind of is some form of standardization between side chains, and I'm just proposing to use it.
Interesting. So basically you can like deposit some arbitrary bytes into different places, basically.
Yeah, so the idea is just that the owner of the token can update the bytes, whatever he likes, right? But what we usually do is we put the token into the ownership of a contract, and the contract has some kind of like rules implemented. So for example, if the data structure that you use is a Merkle tree, then to write into it, it will expect a read proof and then an update, right? And to read from it, it will expect a read proof and stuff like that. So together with a smart contract and using this kind of standard, you can enforce your data structure to be kind of correct, even when you put it into some side chain, and then you take it back out and then you put it into another chain or sell it on some NFT market or something like that. And I'm just proposing this as kind of a vehicle to transport data across chains.
Yeah, there can be some grammar rules as well, basically a smaller version of programming language where updates can happen through that grammar only. I'm just thinking out loud, basically.
So I'm working on another one that's called EIP 1949, obviously, which is about delegated minting. I think I've talked about this a couple of times, where the cost of the NFTs are are usually at the front when you mint them. It's pretty expensive. While later transferring them, you don't save much money using Plasma, right? Because you had all the minting costs at the beginning already. So wouldn't it be cool to mint on the sidechain first and then do like deferred minting when it's time to exit? And that, yeah, so I don't know if this is some, I mean, we talked about standardization, and Carl, you've been talking about like the networking layer and kind of using the same. And I think this is a different approach, just looking at the deposit and exit function and trying to deduct a standard from these two functions.
Cool.
Hi, Jonathan. I have some question. We are hoping to do some POC project for voting as well, voting project. And you said you used the data for NFT used for the voting system, right? And how did you treat all the voters' data as an NFT?
So the question is, how did you store the voters' data in the NFT, right?
Yeah.
Okay, so first of all, let me describe the setup a little wider. So there is two tokens involved here. One is called voice credits, and the voice credits are given to the users at the beginning. And then there is a token which is called votes, and these tokens are given to the booth contracts. And what the voters can do, they can go to the booth and exchange voice credits for votes, which are then sent into a ballot box. So basically, if you want to see the result of the vote, you just query the balance of the balance box contracts, and then you know. But it can happen in quadratic voting that, for example, I first put in 5 voice credits. No, let me put in 9 voice credits and I get 3 votes, right? And then I put in, but then I decide to increase and I put in another 16 to get 25 in total, which gives me 5 votes. Does that make sense? So for that, I need to know how much I invested before. And this is where we use the token. And we model it very simple. So we have, let's say we have a max of 512 things that can be voted on. So each of the proposals gets an ID starting from 0 to 512. And then we have a Merkle tree where each of the proposals has a position in the Merkle tree. And when there is changes made, like every time when someone votes, he needs to bring a proof about the position in the Merkle tree with the ID of the vote together with the transaction. And then the Merkle tree is updated. And then we store the root of that again. And then we store the root of that again in the NFT. Because it's only 32 bytes, we can only store the Merkle root of the tree. Does that make sense?
Yeah. Thank you so much for giving us summary of that.
I don't know if we have a description somewhere about the project, but I'll send it later.
Cool. More topics. I know Peter just joined the call and submitted a pretty hefty.
I just delayed for 30 minutes because of time shifts. Sorry. Yeah, so I would like to discuss one more topic about OVM and DEX predicates.
Do you want to share your screen?
Yeah, let's do this. As I would like to introduce you, Ivan. He's also working with me. And
hi guys.
Yeah, he do a lot of research about this topic, and probably I will give him a speech so he can describe our idea. So the general thing that we want to build a totally decentralized magic engine for DEXs, and this is example how we can work with the futures, the DEX futures engine. And we start research like what kind of predicates we need to build this system, how we can use OVM to make it completely trustless and decentralized. And we would like discuss this thing. So I think it will be the next step, like after micropayments on Plasma. So we want to build some more viable like DEX. So Ivan, would like to discuss this thing?
Okay, I try it. I write this document after reading articles about OVM and posts about predicates by Cryptoeconomic Labs. So we suppose that there is only one futures contract, and suppose that every trader can have only one relationship with the contract. This means that if trader sold this contract, he cannot buy it again in this cycle. Let's suppose that we have only two traders, A and B, Eris and Bob, and let A stay in ask position and B and bid. Let's denote this function is set. This is predicate, which means follows. This is function from two arguments for begin, only two arguments. And like every predicate that takes true or false value. For example, is set from A and B. Here, A and B know such traders. This is more like orders, more like position of these traders. And if it's set equals to 1, that means that there is settlement between A and B. So if we try to write futures contracts in this language, it means be follows. There is day, or currently say date. There is date such that is set from A and B is equal to 1. Let's denote following predicate. I named it is transfer. There are situations when I sell my contract to another trader, or maybe in a situation where I want to buy contract from another trader on this exchange. Is transfer is a function of two arguments again, which again is equal to true or false, and equals to 1 if I sell or buy my contract. For example, if me and Peter, if for example, if I have a contract and want to sell it to Peter, is transfer me and Peter is equal to 1. So suppose that we have three traders, A, B, and C. And first of all, A and B has a contract. I explain it in this picture. There is one block, which means that A has a contract with B. And later I try to suppose all future situations which can be. First of this, A can transfer his contract to C. Second, B can transfer his contract to C. And third, there is date such that is set a function from A and B is equal to 1. Third situation is the finish situation. After this, the round future. And from each situation, first and second, there is next step. Again, we try to explain future cone. Is set C and B is equal to 1, is set, and it means that is set A and B is equal to 0, is set AC equals to 0, and for another case.
Yeah, so there is a third case that is more complex and describe all the different kind of states. But I would like to pause on this state and discuss these options, just to make it simple. So the basic thing that if we will build this set of predicate, it looks like we can build like a total decentralized DEX based on OVM. And I would like to discuss a proposal to get like group to work on this, maybe with the Plasma group, with Cryptoeconomics Labs that we discussed before, and make some prototypes till September, maybe to DevCon, and show how it works. So as Cryptoeconomics Labs say that they want to rewrite all the things on Rust, and so maybe we can go together and implement Plasma Cash implementation together. We can do, along with Alex Vlasov, we can do the snark that helps with exits and data compression. build this basic OVM prototype and present it. So this is my proposal, and I would like to know about your comments and proposals, or some questions, whatever you want.
Yeah, we were actually looking for some application builder on top of our OVM design as well, to showcase like
yeah. So here we are. Yeah, I really like that you do, and I think
this will be like one of the great examples. So please do something together with us.
Yeah, so let's discuss it after. Perfect. So nice. Yeah, so if you have any updates or comments or questions about this set of predicates that combine all the logic that we can put to OVM.
Yeah, I know we posted
yeah?
Right, we posted on atomic swap design, predicate the speech and logic on Plasma build, but we were recently being busy with implementing building stuff for client side and everything. So we're kind of away from the researching phase. So we will make sure to go back on the speech and logic for atomic swaps as well. So yeah.
Perfect. Okay, so I think we'll get a more detailed discussion about this thing. So anything else? Yeah.
I was just going to say I have a question about the thing you just showed. Did you say, so is this a futures contract?
Yeah.
Or is this, okay, this is a futures contract. Okay. And so is set or this is when the futures contract expires?
Settled, yes.
This settlement day, yes.
Settlement date. Ah, yeah. Settlement is settled.
Yeah,
oh.
Exactly. That's why we need OVM to predict all the different kind of states that we can.
This is different things. There is function is exists contract, which means that A and B has a contract, and another function is set. This function means that there is settlement day. And all this function important for exchange, because important for exchange and the OVM concept, because we need to strictly timestamp which allow us to do future call.
Very cool.
Yes.
But the main problem, one of the main problem here, that there are big
complexity
of this conus, yes, and we must to try
to shrink this OVM conus as narrow as possible. So this is the biggest challenge. Otherwise, we can increase the tick size of DEX, so don't do it too often. So in order to make it more viable and sustainable.
What do you mean by that?
I think with every new tick of DEX engine, there is a lot of new possibilities open. So this conus of a different kind of states could be it could increase too fast. So we need to calculate what kind of what speed of our DEX we can afford in our solution.
Got it.
Yeah, so this is a separate research that we will do on the next week, because we want to settle up. Alex Vlasov give me also a nice idea about how we can settle up all the things in decentralized manner. Like we can match all the trades automatically and calculate some these orders in terms, like we want to build the maximum trading volume. So if we will do decentralized exchange that will match all the orders to satisfy this parameter, it will be very hard to manipulate with the market from one side, and from other side that is impossible to do front running on the system when all the orders matching at the same price. The price where the price where all we get the maximum trading volume on DEX. So it's very healthy condition, and I think it will be a good point to build it. But first, we want to just make a trades decentralized, not the matching engine. So it will be the next step. Yeah. So that's it. One more point so I will make a post to leverage article on ETH-Research about Gluon Plasma. So I mentioned about some vulnerabilities that I found, and we can continue discussion on the forum. So I will prepare some detailed analysis of attacks that we can put on this for account-based plasmas like leverage. So yes, I'm also open to discuss different kind of architectures of plasma, and I can say like what kind of attacks is possible to do on this. It's also a very interesting topic that I am continuing research for a plasma cache and different kind of account-based plasma as well. Yeah, so that's it from our side. Thank you.
Cool. One random comment. So what are your thoughts on like kind of the batch auction where you have a bunch of people settle at the same price versus simply doing an order book, but using a hash time lock to conceal what the actual orders are. So essentially, like you have people who have open orders, and then someone wants to match that order. They send a message to the aggregator that has the open order, and then but they send the message and they get a commitment that the message will be included before it is revealed.
Yeah, this is a good point, but there's a very simple attack that we can do. We can simply put a lot of orders in opposite directions and then reveal just that one that we want to, and don't disclose the other. And we can easily manipulate and front run the system with this point. From other side, we can protect from censorship of plasma. If plasma operators stop to accept some kind of transactions, we can also do any kind of protection from this kind of attack from the plasma operator. This is a 2 point that I don't know how to figure it out, but yes, I am also thinking in this direction. Yeah, it's a good question. It's a good approach.
Yeah,
please more brainstorms like this. It's also interesting.
Yeah, we definitely need that kind of research so very badly. But first, we need to build the base layer a little bit more.
Yeah.
But with the sending a bunch of orders, yeah, I wonder like how to do some kind of like anti-Sybil mechanism. Yeah, it is quite tricky.
Yeah, one more comment, like from other side, if we start to slash people who doesn't reveal their orders after hash lock, so it will be very easy attacks with just availability. If people just doesn't have access on time to the internet and they just simply can't reveal, or some DDoS attack, and we can protect from this side of attacks. So we can slash people because of that doesn't reveal their commitment. So it's also a tricky thing from other side.
Yeah, because then you have to like compute all of these whatever commitments and actually unlock them. Yeah. Oof.
Yeah. So it's very interesting, but it's also the point of separate discussion about this. Yes, so let's moving forward. The OVM is very great idea, and I would like to move it forward and make some prototype for the next few months.
That's awesome.
Thank you.
Anyone has any resources on OVM beside the Plasma, the blog, basically? Some kind of specs or you know any kinds of notes would be even better to understand it more.
Right now, the material on the OVM is very, very sparse. Unfortunately, I will send maybe I'll like there's some like HackMDs that have some rough outlines, and there's a bunch of random documents. I can like link to those. Maybe I'll throw together a plasma.build post that just is like OVM resources or something like that, and it's gonna have like 3 links on it, unfortunately. But more to come. We definitely need them.
We are also planning on to publish all these like architecture design diagram for OVM pretty soon. So yeah, stay tuned.
Cryptoeconomics.
We started to implement it with Rust.
Yeah, in Rust.
With Rust, so you can see, you can check.
Yes, and we are implementing in TypeScript. So
yeah.
we got 2 implementations going. Yeah, we should actually sync up on some changes to the client architecture. They're not big changes. It's just basically making sure that we can account for when a user sends a message, how do we update the OVM to account for the fact that the user sent a new message, and how does that affect our prior decisions? And so that's a sticking point. I don't know if y'all had that as a sticking point for like a bit of a difficulty, but yeah. And also, Cryptoeconomics Lab, you said you had some questions. Is that the case?
Yeah, we were just discussing it before the call started, like where the DB sit on the client, and also how do you construct all the properties, and then we should make sure that there's a way to standard how to construct it, all the properties. And also, yeah, how to construct a property that fits the limbo exit, and stuff like that. Yeah.
Yeah, I think revisit is most complex case now.
So one way to do limbo exits is actually what you can do is you just make a claim, at least let's say for just a simple transfer. You can make 2 claims. You claim that the transfer happened, and you claim that the transfer did not happen. And you submit both of those claims, and you say you can even contradict them yourself. And then you wait the timeout, and eventually either someone will say, oh, show that it did happen, or the timeout will elapse, and the proof that it doesn't exist, that will be decided. And so then you decide the thing that doesn't exist, and you contradict, and you delete the contradiction for the thing that does exist. Does that make sense?
Yeah, maybe okay.
Great.
Thank you.
We have to more, but yeah. And also DB, like database.
I think
but
okay.
Yeah, it may be like two specific questions, and other participants won't be like that and just interested. So maybe we can just talk in the Telegram chat.
Yeah, that sounds good.
Yes, by the way, the guys from Cryptoeconomics Labs and Yurika, you said about atomic swap predicate that you You also, Ivan, just send you question to 2 weeks ago on Plasma Build. I sent to the Zoom link. Please check it out, and we would like to discuss. So this is the one who send you comment for a predicate.
Thank you so much.
Yeah, so we already check atomic swaps, and we can continue discussion about how we can combine all our efforts together.
Okay, great.
Yeah.
Okay.
Hey guys, how can I get onto that Telegram, the OVM Telegram that you're talking about, or?
I don't think that it really exists yet. I think what I'll do is after this call, I will do two things: make a plasma.build post, and also maybe throw together some OVM implementation Telegram group. I feel like it's reasonable.
Okay.
Yeah,
Carl, I sent you my Telegram username like 2 weeks ago.
Oh.
You can send
somewhere in your emails. So invite me to anything.
Perfect. Cool. Any other? Sorry.
Yeah. One other thing. Shuhei just really wanted to know about your optimistic roll-up so badly. So maybe
Ooh.
for the remaining time.
Okay. Sounds good. I will go on a little bit of a rant. So optimistic rollup. Why is this cool? Well, it allows for in the kind of the base case, you can get probably, my guess is like 5 to 10x scalability on top of Ethereum as it is today, without actually changing anything about the Ethereum security model. Like very little, basically. How do you do this? The general idea, and I think that this actually will end up being a very important component to this kind of whole layer 2 future. You can kind of think of this as a layer 2 of layer 1. So it has the layer 1 guarantees, but it's using the OVM for basically the scalability increase. So the way that you do this is you embed a stateless Ethereum client inside of Ethereum itself. And so how does this actually work? Well, you're all of the transactions that you send, you're sending them into the call data. You're not sending them into the actual, Ethereum state. And then what you're doing is you're committing the transition, kind of the result of that transition, as we would normally commit a block, block root. And so what that kind of gives you is that gives you the ability to lazy evaluate or optimistically execute all of these blocks. And so a user can actually like download all of the different blocks, check if they're valid, and follow that chain. And the important thing is that we don't have the data availability problem using this because it's a roll up, right? So that means that we actually technically can do things like forking. So we actually can avoid any capital lockup from an unavailable aggregator. We can instead kind of like just fork around it. And it gives us smart contracts. The important part that is a little tricky, and I bet kind of Johan has experienced this, is actually validating that these state transitions, if you have an expressive enough state transition function, it gets very difficult to evaluate. So it turns out there is a way to evaluate state transitions on chain that is one, you can use SolEVM definitely, but there's also an interesting scheme that I came up with that doesn't even use SolEVM and allows you to actually run the transactions themselves directly on main chain Ethereum and still be able to get the same results. And so that's an interesting application. So this is a very interesting design space, as I'm sure Shuhei you are aware now. and we should talk about it more as it kind of progresses. But it's very, very cool.
So we were also thinking on the same page, like basically every transaction is stateless, but we had faced some issue regarding the state data being too large. So in that case, how do you prove on chain basically? So then we got stuck on the same problem, like EVM on EVM kind of stuff and all.
Yeah, exactly. So maybe what I'll do, because it's a little bit of it's a funky scheme. And we're kind of running out of time. We can talk about it later. Maybe I'll write up a little post about how one might be able to do this. But also shill SolEVM, maybe SolEVM. But yeah, this is a very cool area of research.
Sure. We were having some random thoughts basically. So to the layer 2, we can use it as a computation layer, and in that let's say that layer 2 is some kind of OVM or something like that, and inside of that OVM you can directly access the storage basically. So let's say IPFS. So you just instead of providing the whole state, you provide just the hash of that IPFS storage, and inside of EVM you can directly access the state data and execute the whole transaction and update the state. So it would be easier to prove on chain, but I'm not sure we can provide that same kind of connectivity inside the Ethereum where we need to prove the whole thing basically. Or maybe we can bisect the whole transaction and just prove one opcode maybe. I'm not sure about the specifics here.
Yeah, the general problem is like you need to make sure that your transitions, whatever they are, right? You need to make sure that your transitions are small enough to be verified. And so if you transition each bytecode, like, yeah, that will be verifiable in Ethereum, but then at the same time, it will be totally infeasible because you have too many commitments. Yeah. And so you need to make sure that you have this like transition size and commitment trade-off. That you're not committing too much, but you're not committing too little, because then if you commit too little, maybe it's too hard to compute on chain. Yeah, so this is a bit of a trade-off here, and I think that there is a reasonable like commitment size or transition size where you can actually like verify one of these transitions using a full Ethereum block or something like that, or maybe like half of Ethereum in Ethereum block, and like you just kind of split it up in that way. So these blocks are kind of like mini blocks. But yeah, we should. I'll put together a post, which I meant to do a few days ago, on this kind of design, and I think it'll be pretty straightforward. And I think this can serve for the OVM as the kind of base layer for the that we can even route plasma chains and state channels in.
Yeah, multiple computation layers basically.
Yeah. So anyway, it's exciting times, I think.
So sorry guys, I missed a little bit. Can you, in one sentence, kind of summarize how SolEVM could help or not help OVM to achieve what it wants to do?
Yeah. So essentially, the sticking point is we can use the OVM to essentially optimistically evaluate blocks that are committed but not evaluated. And the problem with doing this is that we need to be able to, in the dispute case, evaluate whether or not that block transition is a valid block transition. And so SolEVM could technically be used, I believe, to validate the transition from block to block. And that is, definitely a very, that would be great. Interestingly, by the way, if we have a WASM interpreter as well as a EVM interpreter / I have a janky scheme that allows us to get around the EVM inside of EVM, which I'll share. But essentially, if we allow this, then you can both do EVM transitions and WASM transitions. But anyway, hopefully that answers your SolEVM question. I just started randomly talking about WASM because it's cool.
Yeah, I think both of these are open and it's interesting. Just to kind of add to that, so in SolEVM, we've built in a plugin system that we call the, I think the interceptor or something like that, which you can use to kind of, the moment when you prove in a specific opcode, the interceptor is the one that chooses from like all the state that was available in this transaction or in this block to just the things that you need in this specific opcode. And maybe this is the point where they could integrate. So if anyone is interested to kind of follow the SolEVM path, then I can talk more about the interceptor design. And I can publish something about that as well. I think we have it in the docs already, but it's not very like newbie friendly. So yeah.
Cool. We should really talk about this, because I think whatever this optimistic rollup layer thing is basically a common good. So we should, commonly work on it. I don't know. And your work, I was running all your tests. You have 1,200 tests for the SolEVM repo.
Yeah,
my
site always spins up.
It is so bad. I mean, it's not bad. It's great, right? But it's like, wow, that's a test suite, for God's sake. Anyway, I guess with that, let's all stay in touch, and I'm really looking forward to the next call.
See ya, guys.
Yeehaw.
All right. Bye-bye.
Okay, thank you. Bye-bye. See you.
Thanks.